Alright, so first we're going to talk about how to find the prime factorization of 75. First things first, when you're finding the prime factorization of a number, you want to think about a pair of factors whose product is 75. Your first inclination might be to say 1 times 75, which would be correct. However, when we're doing prime factorization, we don't want to do 1 times the number, so we want to think about a different pair if we can. The next pair that we're able to consider would be 3 times 25. That's the next pair that pops into my brain. So you make what we would call these, or refer to these as branches. 3 times 25 equals 75. Now I'm going to think about a pair of factors that would give me a product of 3. The only pair is 1 times 3. If the only pair that you can think of is 1 times the number, we consider that number to be prime. So 3 is called a prime number. We're going to circle the prime numbers. Remember, the goal here, we're doing prime factorization. So we're going to break 75 down into all prime factors. That's the entire goal. Alright, we're going to think about 25, a pair of factors that can give us a product of 25. 1 times 25 is 25, but there's an additional pair, 5 times 5. So we want to use the additional pair if we can. Alright, we've already know that 3 is prime and therefore it can't be broken down any further. So we're going to try and break 5 down next. So if I think about a pair of factors that would give me a product of 5, the only pair is 1 times 5. That makes 5 a prime number. We've actually are finished breaking down 75 into prime factors. Now this is called a factor tree, kind of looks like a tree. The prime factorization of 75 is then going to be 3 times 5 times 5. The tree is not the answer. This tree is the work that we use to get our answer. Our answer is 3 times 5 times 5. However, normally we simplify this if we can using exponents. Remember that 5 times 5 can be written as 5 squared. So our final answer here is 3 times 5 squared. Let's try another problem. Number 2 is asking you to find the prime factorization of 90. So you want to think about a pair of factors that you can multiply together to get 90. Now, my first thought is 9 times 10. Another thought is 2 times 45. I can use either of those pairs and I'll still end up with the same final answer for my prime factorization. So I'll go with my first thought of 9 times 10. Now I'm going to look at 9 and see if I can break that down into primes, or is it prime? Well, if I think about 9, I can certainly do 1 times 9, but it does have another pair of factors, 3 times 3. So I'm going to break it down into 3 times 3. Now I'm going to try and break the 10 down if I can. Well, of course you can do 1 times 10, but you also have another pair, and that other pair would be 2 times 5. Now we discussed in the previous problem that 3 was a prime number, so we can circle that. We also discussed that 5 was a prime number, so we'll circle that. Now we need to consider if 2 is a prime number. If it's not, we need to break it down. So we think what factors, or what pair of factors would give me a product of 2. The only pair is 1 times 2. So 2 is also prime because it can't be brought down or broken down any further. Now again, this is not the answer. This is the factor tree, which helps us get the answer. Notice I have all primes. This one looks more like a tree than the previous problem did. So I'm going to rearrange these prime numbers in ascending order, meaning smallest number first. I'm going to write it as 2 times 3 times 3 times 5. Remember, it's all multiplication. It doesn't matter what order we multiply in, so that's why I can rearrange it. And then we just want to see if you can rewrite this using exponents, you want to do so, and you can. Remember that 3 times 3 is the same as 3 squared. So my final answer is 2 times 3 squared times 5. Let's try another one. The next problem is asking you to find the prime factorization of 51. Well, off the top of my head, I am not certain what pair of factors would give me 51 other than 1 times 51. However, I can do a trick to see if 3 is a factor, and that trick is if you add the digits. If I add the 5 and the 1 together, I get a sum of 6. I know that 6 is divisible by 3, therefore 51 should be divisible by 3 as well. That means 51 is not a prime number, and it can be factored into 3 times something. Now, I don't know what to multiply 3 by to get 51, so that's why I'm going to come over here and divide. 3 goes into 51 just once, and 3 would go to 21 7 times. So it looks like 3 times 17 is 51. We already know that 3 is prime, so we'll circle that. 17. The only way to get a product of 17 is to say 1 times 17. Therefore, 17 is also prime. I'm finished with this one. The prime factorization of 51 is just simply 3 times 17. There are no exponents that I would need to use in writing this one. Let's try one more. We've got 95. Prime factorization of 95. Again, I'm going to think about what pair of factors would give me a product of 95. I immediately know that I can multiply 5 by something to get 95 because it ends in 5. If a number ends in 5 or 0, then you can divide it by 5. Actually, in this case, 5 times 19 is going to give me 95. We've already discussed before that 5 was prime, so we'll go ahead and circle it. 19. The only pair of factors for 19 are 1 and 19. Therefore, 19 is also prime. I can't go any further. I'm done. The prime factorization of 95 is just simply 5 times 19. Actually, I said that was going to be the last one. I want to try one more. Let's do number 5, which was asking for the prime factorization of 59. Alright, for this one, I don't immediately know of a pair of factors that would give me a product of 59, besides 1 and 59. So let's see. It's not divisible by 2 because it's not even. If I try to see if it's divisible by 3, remember I add up the digits. 5 and 9 give me a sum of 14. 14 is not divisible by 3, so neither would 59. Okay? Let's see. 4 doesn't go into 59 evenly. I know it's not divisible by 5 or 0 because the 1's digit is a 9. It's not going to be divisible by 9 because the sum of the digits is 14. 14 is not divisible by 9, so that doesn't work. It's not divisible by 6, so it seems to me like this is actually a prime number. In this case, you don't make a factor tree because it's already prime. So we would simply just say that it's already prime.